Hey, I'm Taylor Dorsett, and this is the Professional Technical Interviewee. Technical interviews are hard, and every company does them differently. On this show, I interview engineering leaders to see what they look for in technical candidates, and then they perform a real technical interview with me. I hope you enjoy.
Great. Well, we are back. Well, the ball is in your court now. I'm ready to interview with the man who's done over 1,100 interviews at least. So
that's just the mock interviews. That's just the mock interviews on one platform. Yeah, I've done probably a few thousand mock interviews. I've done several hundred actual tech interviews, where I've conducted them, and I've been the candidate in many dozens. So for the scenario of this, since I don't actually work for a company right now, we're going to pretend I work for an e-commerce company. And so I like to kind of tailor my questions appropriately. So the main prompt for this is my e-commerce company wants to come up with bundles of things for people to buy. So I'm going to give you a price point, hey, for $25, what can people buy? Come up with a bundle. Or for $50, come up with a bundle. For $10, come up with a bundle. If you can't come up with a bundle, just give me back an empty list of things. But I'm going to provide you a menu or a catalog of things, and I'm going to provide you a price point. And your job is just figure out for that amount of money, what can I buy? A couple of key things here. We want to spend all of the money. We don't want any money left over. And the second thing is you can buy any item multiple times. So headphones are on the list. You can buy as many pairs of headphones as you need. Or there's a cheap mug on there. You can buy as many mugs as you want to spend that money. So those are the two main things. You can buy anything multiple times, but you have to use all of the money. You have to use 100% of the money.
Okay. Let me just make these notes here real quick. Can buy anything multiple times and have to use 100% of money. Okay, yep. Got it.
So around line 16, I've given you some information about the inputs that you can go through and kind of review as far as the money amounts and so on. And then I give you a really simple example around line 22 now, where if all we have is a pen and a comic book and I give you $10 to spend, this is the only possible answer. Some of the values that I'm giving you as test cases may have multiple answers. And so you can just stop as soon as you find the first answer. We're not trying to find all of them. So as soon as you find an answer, you can just stop processing it. And then I give you an example menu that we're actually going to use for a bunch of test cases, and we'll kind of work through them from there.
Got it. Okay, so this is going to be one of my questions, because we can buy something multiple times. It's possible for us to have all cheese if that was the first one we ran into.
Correct.
Great. Okay. So let me just read this over one more time to make sure I understand. Platforms gift bundles at different price points. Several price points. That's not good. We can offer in each bundle. Great. So we're always using 100% of the money, right?
Yeah.
Covered that. You can add any item as many times in the bundle. Great. Our inputs, we're gonna have somewhere between $0 and $100. Okay. 1 to 100 items in the catalog. Great. And I'm assuming we have 1 to 100 items in the catalog. Those could be, any different prices between also 1 and $100 or 0 and $100.
That's right. Yeah, every money value you'll get will always be greater than 0, but no more than $100. And the catalog items here is basically you're always going to get at least one thing in the catalog.
Okay. And even though using the term bundle, it's fine if there was just one item, right? If we had a $100 item, that's perfectly fine.
Yep, absolutely. Yep.
Okay, got it. Great. They're unique to each other. Don't worry about shipping text. That makes things much easier.
Yep, for sure.
Okay.
I realized as well, the example I gave you on line 32 through 35 is not accurate with the actual example menu that I've given you, but that would be another example of where if you had an exact amount of money to spend, you might have multiple answers. And that's just to say you can stop as soon as you find an answer, and it doesn't matter what order the items come back in. So as long as we spend 100% of the money, just give us the first answer you find.
Got it. And are these do these align with this? Like, is there always these test cases we have right now? Is there always going to be something in here that adds up to $10?
That's a great clarifying question. I will say you are not necessarily guaranteed that there will be an answer for any given amount of money. Like I could give you a $1 test case, and there's nothing on the catalog for $1. And so I think I mentioned in the inputs or on the prompt, if you can't find an answer, just return an empty list. If you can find an answer, it should be a list of strings. Either way, you're going to give me back an array. It's just whether it's empty or whether it contains information.
Okay, so list of strings if found, or an empty, or just an empty string.
Just an empty array. So
Empty
either
array.
way, you're giving me back an array. It's either an empty array, or if it has things in the array, we're going to assume that that adds up to our amount of money.
Got it. Okay, great. All right, this makes sense to me. I'm trying to think of other clarifying questions. So just looking at this test, if we had $10, what we could do is show my math skills. 650, we add 150.
This is also why I gave you a much easier example around line 23 with whole numbers. So use that as far as like walking through what what the process might be. It'll be a lot easier to think through here.
Yeah. Great. Okay. So yes, if we have a fancy pen and 2 comic books, that equals $10, right? Okay, great. So that example makes sense to me. If instead we had $11 here, we would want to return an empty array because there's no way for us to get to $11.
Actually, there is. We could buy 2 pens and 1 comic book, and that will give us $11.
Yes. You see my math weaknesses here. All right. So with $11, we would have 2 pens and 1 comic book. With $2, we would get an empty array because there's nothing that would be less than 2. Yes. Okay.
Correct.
Great.
Yep.
Great. And if we had $100, it would be some combination. Well, assuming that, I think you could make that math work, but it would probably we could
be a lot of fancy pens.
Yes. Yeah, a lot of things in there. Okay.
Yep.
Great. The only thing that it's an interesting question. I'm trying to think of other constraints, but I think this all makes sense to me. I understand our what we don't want. Is there any, I don't really know how to code this, but I'm just asking, is there any way, do you have a preference on there being more than 1 item in there? I'm assuming if this was a real use case, we would, right? Because it's a bundle, but for this coding question, do you have a preference? Would be more than 1 item per bundle?
Yeah, so all of these bundles will have more than 1 item from the catalog. And it will probably be necessary to buy an item more than 1 time.
Okay.
At least for the test cases I've given you. For example, if I gave you a bundle amount of $6.50, there would only be a single item. Or if I gave you exactly $13, it would be just 2 novels, but it would still be like one item from the catalog, but you're buying multiple of them. But in this case, for these test cases, I believe you will always have like a number of items in order to solve it.
Yep. Okay. Great. So looking at this, so I start to pseudocode here. So I'd want to, if I'm thinking through it, I'd want to just starting out.
So go back to the pen comic book, and $10 example. Like think through that one because it's going to be a lot easier for the math. Like how would you actually start looping through these to figure out what you could buy and when you need to look through the menu for other things?
Yeah. I guess it's going to require some division. So basically taking this input and seeing if it's divisible by anything on this list, might be how I would start. So if it's cleanly divisible by anything on this list, right? So we could check through the options. If it's not, then seeing if it's divisible by some combination of these things, or if it's
So try not to get too complicated on the math side of it. Not every problem is going to be like, oh, there's like a math formula or a math trick to solve it. This one, there's no particular math trick. Just think through, like, from a simpler point of view, like, let's imagine there's a food truck outside and they got a $4 sandwich and a $3 salad, and you have $10 to spend. How would you explain to somebody how to spend that $10? That's usually how I would get started on pseudocode, is just tell me at a really high level, like, what are those basic steps to follow?
Yeah, I'm trying to think of if we want to like basically eat up as much of that money as possible and then check to see if there's anything else on there, right? That might fill up that amount. That seems one way that would be easy if there is that, whatever that remainder is. Another way well, that's the one that immediately comes to mind. And basically, if that isn't there, then we would maybe remove one and then look through to see if there's any other item that would eat up the remainder amount, right? And then we can continue to do that.
So in this case, we've got $10 to spend. So if we kind of follow that expensive item first, so we're going to buy a pen. We got $6 left. What are we going to do now?
Right, we got $6 left. So, and how I was thinking, right, is we would buy as many as possible of that thing. But if we've got we bought our pen, we could buy a second pen, right? But then we recognize we can't buy a third pen. So we look through the list, and there's nothing for $2, right? That will fill up the remainder. So we're going to take one pen off, and then go back and look at the other items where we have a 3, right? So then we'd add one of those that would get us to 7, and then we would add a second 3, right, to get us to 10.
So if you were to work that out as like an algorithm of pseudocode, then we need to loop through the catalog, and then we're going to try to buy what we can afford. So if it's too expensive, we'll skip it. But then we effectively have to figure out how we're going to repeat that work. And, there's different ways that you can kind of nest that or repeat that work. And handful of pros and cons either way on that. So if you were to like pseudocode out what those steps would be, what could that start to look like from a pseudocode point of view?
Yeah. If we have our function takes in, we start with this menu, right? We takes in an object.
So we'll have in this case the menu and like a target amount.
Oh, and target amount. Okay, right.
Because we have to know how much money we have to spend.
Dollars to spend, right? So then within that, some type of for loop, or for if we're using an object for a different type of some type of for loop, right, to actually loop through that object. Within that loop, well, in my mind, it was take the most expensive one, but really it could just be the first one. Like if basically find or buy first element.
Well, in this case, you're just going to buy the element that you're looping over. So wherever you are in that for loop, we're just going to try to buy that item.
Yeah, that makes sense. And if I guess I need to track dollars spent.
So if we can afford it.
Yeah. So like spent, something like that, right? By element if dollars spent allows.
Okay.
It's some type of basically if we can't buy that, in my mind, it was we would come basically remove one. So let's see, remove one last purchased item, and then basically continue through our loop.
Okay, so let's break down line 58 a little bit more. So how are we going to buy that item? What's that going to look like?
Yeah, so we would need create basically results array. We could call that something better, like items purchased, right? That's going to be our end result. Geez. So if dollars spent allows, and we're just going to push it to items purchased.
Okay. Now, how will this allow us to buy the same item more than one time? Because right now it looks like we're gonna buy one thing, and then we're gonna go back up to that loop and buy the next thing. But in this case, we may need to buy the same thing more than one time. So we need to figure out how do we kind of repeat all of this effort. But now that we've bought an item and we have less money to spend, how do we sort of repeat that work with the remaining amount of money?
Right. Well, we wouldn't actually need I said push, but I guess I mean make a reference to that item. We're not actually pushing it, it's just pushing pushing the key into it, right?
Okay.
Or a copy of that key into it. Remove and add value to dollars spent. So we'd also need to update the dollars spent within that. Okay. You said repeating. How would we repeat that?
So going back to the initial problem of like the pen and the comic book. So
yeah.
We buy a pen, we have $6 left.
Yep.
So how do we repeat that? So do we try and buy like just as many pens as we can and then realize like, hey, there's no answer, so we need to put a pen back? Or do we immediately like buy one pen and then move on to comic book? Like at what point does your algorithm decide whether that found a solution and then whether to move on in the menu or keep trying to buy that item?
Right. That makes sense, because as is, if I'm just looping through, it would use that one and then go to the next one, right? Which is not even what I'm describing. So good question. How are we gonna, we need some type of I think some type of if check where we're seeing if
this could also just be where we have another loop inside maybe of, you know, let's just try and buy that item as many times as we can. Or like you mentioned, you know, do some sort of division math to figure out like how many of those could I buy, something along those lines. We want to be careful not to overspend our money. And so we need some sort of mechanism inside of here figuring out like how many of those things do I buy.
Yeah. Same check as above. So that makes sense to me. Basically, we have this if, and if this basically, if we can buy one of them, right, then let's trigger a loop where we try to buy as many as possible, right? So it'll shove. In our example, well, it has the other way around, right? But comic book in there. I guess we could spend that money. No, we couldn't. But if this was $2, right, we would shove fancy pen in there, and then one comic book. In our example, if we're using another loop within that. This is my hand wavy way to say having nested loops probably not our best idea if we're thinking about complexity. But this is the way that I think it would be easier for me to come up with something that actually works using a nested loop than it would be to figure out how to do the math correctly.
And just sort of like out of character for a moment, I'm a big fan of done is better than perfect. So for me, any solution is a better solution, even if it feels like a dirty hack. It's like get some kind of answer, because if you can work that out quickly, you may have time to optimize it and make it better later. But if you spend your time trying to come up with really elegant code, you could run out of time. At which point I'm gonna, as a hiring manager, I'm like, oh, am I gonna risk ever hitting a deadline if I hire you?
Sure.
So but not everybody's going to feel that way. But for me, I like to focus on like, hey, you can get the job done. So any kind of solution is a good solution.
Yeah. Okay, great. So we can loop through that. And else side. So if we can't afford the dollars spent, or we can't add anything, then we want to remove the last item, and then basically it would move on in this loop. So that to me seems like it would work if, well, it should just keep triggering this else clause if I'm trying to think if we're going to keep removing items, if we're not looping, or if it's not the right one selected in there, right? So if we had trying to think of the, so we got this with $2 here.
Do like a soda or something.
Yeah, so we buy a fancy pen, and then using my nested loop, it buys a second fancy pen, right? But then it kicks out of that loop. It's going to go to comic book next. We're not going to be able to afford a comic book, so the else side of that's going to trigger, which is
removing that second
the last
pen
item, right? So it's going to remove the second
which we
pen.
don't necessarily want,
right?
Because we haven't exhausted everything to know. Wait, there was no solution going down that path.
Yeah. Yep. It's almost like instead of an else side, I guess could else if it doesn't, basically if we can't buy something, then continue through the loop, or continue through our items, and if we try to think the way to do this, or talking it out, it makes sense to me. Continue through our loop or our list, our menu, and if we can't find the item, if there's nothing in there that'll complete this, then we want to remove an item. So
but we have to know definitively like there was no answer. If I go down this path, there's no answer, then we need to sort of remove that last item.
Continue through loop, and we would want to basically do the same thing, right? Okay. So again, in this situation, that would add, it would add 2 pins. It would look at comic book, which wouldn't work. It would continue through that loop, and then it would get to bag and add that, and then return our string. I guess I don't know if I guess I don't have any conditions set up other than to return item purchased at the end. So thinking through, when do we actually want to return this, or what's our, we've made it, right? If so, I guess we could do this in each of these. There's probably a better way to do this, but anytime something's being added, it's kind of on the same line, right? But it would be within there. If dollars spent is equal to target, right? Then just return items purchased.
Yep. So yeah, we might need some way of like stopping all these loops because we found an answer.
Yeah, so this would be within this for loop, and within any of these loops, right, we'd have the same type of condition. That'll make sense to me. What is coming to mind is that what we don't have right now is any type of basically, if nothing fits, I think this loop is just going to keep running and running and running, right?
Well, it should stop at some point because the for loops are going to get to the end of the catalog and then terminate. And eventually that for loop on line 59 should then also terminate because it's going to go through all the different sorts of combinations. And eventually it's just going to hit line 66 where it says, hey, we got to the end here. Let's return items purchased, which started as an empty array on line 58.
Right. I'm trying to think if this else is sufficient to return anything that gets added to it. Like, is it still going to be an empty array, or would a bunch of things been added to it and nothing been, not all of them been removed, but.
So we might need a second buffer maybe of what items are we considering? And then once we get to an answer, we make a copy of that into items purchased so that we return that instead of like whatever this buffer is maybe. So that might be one way to think about it.
Yeah, that would be possible. Right. Bundle. Right, we've got some type of array. If we get basically if our at the bottom of our for loop, right, we could just push well, we could have another check where we're saying if dollars spent. Just trying to think of the best way to do that, but I would just want to at the end push possible bundle into items purchased. I think within some type of check, like if the same type of thing, right?
Yep.
Okay. What is your opinion of this?
There's going to be some duplicated effort in here. I'm a big fan of drying up your code, not repeating yourself. We probably don't want to do a hard return on line 61, but we could figure out like, is there a way to stop the loops that we're in? If we get to an answer, is there just a way that we can just not do any of the other loops so that we get to that if check on line 68 of, hey, you know, if we found an answer, then we can like copy our buffer into our final array and then return that. So that would be the one thing that I might coach someone on, like, hey, see if you can like reduce the duplication of effort. But at the same time, it's like, all right, we're on the clock here, so we got to get this thing done. And sometimes that duplicated effort is fine. There are a lot of different ways that we could kind of repeat the work of what we have to do. It could also be like when we remove an item from our buffer, maybe that's where we need to kind of resume through the menu. And so we could reduce the amount of nested work that we have to do. As far as like where do we sort of pick up in the menu or in the catalog of where we left off. So those would be a couple of considerations. Generally, though, I think that this kind of approach is going to work okay. It really comes down to how are you going to repeat the effort, and
Yeah.
kind of, I think you've done a good job recognizing like there's a repeatable sub problem in here, where we have an amount of money to spend. I got to go through that catalog, figure out what I can buy. Now that I've bought an item, I basically have to repeat all that again of I have an amount of money to spend. How do I go through the catalog, buy what I can afford? If that doesn't work out, then I can remove an item. So you've kind of hit on the main points. So at this point, it'll be how are you going to execute on that?
Yeah. Yeah. Okay. On this note of like, rather than returning, if we just want to get out of these loops, I think we could just break here, right? Instead, which kick us out. And if we have this at the bottom already, right? That's our check, which
the thing to be careful of is if you're doing that break inside of the second for loop on line 62, it's only going to break out of that for loop and not the one on line 60. So again, you might need to do some additional checks of like, how do I get out of all of these loops because we're done?
Yeah. Yeah. A question. I don't use breaks often. I return more often. So that's
it also depends on the type of loop that you do. Like a for each, a return is going to sort of return out of the for each. So it's kind of like the break for each, where if you're actually literally doing a for loop, a return is going to exit your entire function at this point.
Right.
So it will depend a little bit on your implementation as far as like, do you do a break, do you do a return, and where to do those.
Yeah, do you have to do a for of to loop through an object, if I remember correctly?
No, I don't think so. I think like if you do like a for each over object keys for your catalog, for example, then a for each would need a return to like sort of exit the loop.
Yeah.
Because break won't work inside a for each. But if you're just doing a for loop, then a break will actually exit the for loop. So again, it depends on the nomenclature you use between for and for each.
Got it. Okay. Okay. So I can start to code this.
Okay. And then just as far as the time check goes, just again, kind of out of character, I've got about a half hour before I got to do a follow-up call.
Cool. Then let me, I'll throw something out there of like, this is what this would look like just to get some of this on screen. And then I think this looping part would be the part that I would probably end up spending time on.
Okay.
That I don't necessarily 100% know how to do it the best way possible. So const bundler. So what was this menu? Menu and target. So we wanted to make some type of dollars spent. It's always going to be a dollar value we're getting passed in, right? So that that would work. We got results that we're always having. We'll let possible bundle. Also have an empty array there. And at the end, we're always going to be returning our results. So this is what I meant by I write for loops regularly like this. Is it let index?
Yep.
So can I do this to loop through an object?
No, you'll have to use you'll need to do like object.keys to look through the catalog.
Yeah.
So you're going to need to do object.keys for menu that's coming in. Whether you can iterate over that, I'll leave up to you.
I don't know.
Well, object.keys should give you an array of those keys. So you'll need to make this less than the size of the number of keys that you have. So you may want to pull that out as a list ahead of time. Just that way you're not like reevaluating that every time through the for loop. So I would just call it like, catalog names or something like that and store that as a list.
Got it. So just that. I don't use.
Yep. And then you'll pass menu as a parameter to keys, and then you'll need like a let or something in front of that too.
Yeah. Got it.
So now you can go back to the for loop that you had, because your I value is going to start from 0 and go to the length of menu names -1.
Yes.
Or just the length of menu names. And then just, I++ or index++. Yeah. Now the second parameter in there, you're gonna have to say index is less than menu names.length.
Oops. Yeah.
Okay.
Okay. So that's my first loop. So so on our current element,
Now in this case, menu index won't work because index is a number. The names are sitting inside menu names. And so the actual name of the item, you're gonna have to look up as menu names at position index.
right.
In order to access that as an attribute of your actual menu.
Yes.
So it'll be like menu square bracket menu names index. That'll give you the name of the item. You'll have to do the same then for the price of the item. So, sorry, this will actually give you the price of the item at this point. So yeah.
Right. Okay. So we wanted to, if dollar spent allows, so if we really want basically target if it's less than or equal to target minus dollar spent.
Yep. Good.
Yeah. Okay, and if that's true, then we wanted to dollars plus equals. This is giving us the price, so we want one of those. And then we wanted to add it to our possible bundle, the name of it. Possible bundle. Which would just be menu names index.
Good.
Is there anything else add to the dollars? If we wanted some type of check where if dollar spent was target, I was going to do return with some type of break, because at the end here we're going to ask if dollar spent is equal to target. We will take possible stop push
Now that's going to
we can
push,
just
that's
make
going
it
to push your
equal.
other array into the array. So result will end up being an array of arrays.
Yes.
Okay.
Right. This should work though.
You might want to unpack that with like the spread operator. So you actually make a copy of it.
Do I have to do that within an array?
Yeah, I believe so. Yep. Cool.
Yeah. Okay. Great. Well, that's I think then we talked about putting another loop within here, right? So if we had more time, it would put some type of loop over same item, right? We had our else if move to next item, right? Which was the second half, and then else remove last item.
Yep.
So those would be the other steps, and basically the loops within that, I think, is when that would get more complex. But I like this problem. It makes sense to me. Actually, working it out is interesting, and one shows me I need to do more actually looping over objects, and then I'm sure some of the optimization can come from, obviously we don't want to do this, this massive amount of looping every single time,
over and over
right?
and over.
So how else could we do this? And you alluded to potentially recursion is something that we could do as well, which I think would be helpful for this. And there's probably also some division stuff that would, if we're looping through objects, we could probably just check if the remainder of what we have for dollars spent and target is filled by any of these things, right? And get it that way as well, rather than actually.
One thing that we could do in here is we could change the if on line 82 to be a while loop, and just say while I can still spend the money on this item, just buy this as many times as possible. So we can just literally turn that into a while loop and remove the if statement on line 85.
Sure.
So just change that to while, and then get rid of lines 85, 86, 87. So this is basically going to say, like, for whatever this item is, buy as many of those as possible. And now I can see, like, if I have money left over? Did I hit my target? If I hit my target, I'm done. If I've still got money left over, that's maybe where I need to kind of loop and try things again. So overall, like, the process was good. Like, thinking through the problem, you asked really good clarifying questions. So all of that was super important. Kind of like repeating the question back to me in your own words is super important. Like, do you get what it is I'm trying to ask you to build? And then asking the good clarifying questions, and then the pseudocode. Now, when you're writing out pseudocode, I would actually go even simpler than what you wrote. So let's go back to your code. I'm going to coach you through how I would write pseudocode for this. And we'll give you some ideas.
I always end up
maybe.
I feel like I end up like overcomplicating it, where I end up like basically like I've tried to make this even simpler, because I used to go, let, and then I realized I'm just coding, but with comments around it.
Exactly. Yeah. So let's do this. After line 72, let's just open a multi-line comment. So we'll just do like the /* after 72. And what I'm going to do is I'm going to coach you how I would write out pseudocode for something like this. So just single slash with a star and then the */.
So we're
no spaces. So yeah, so slash and then a star right away. Yeah, there we go. And then */. So what I would do on this is I would literally write this out like, okay, I need a function. I'm just going to call it fn for function. And I need to pass in some parameters. So I'm going to pass in a parameter of my catalog, and I'm going to pass in a parameter for my target. So I'll put those parameters in parentheses just so I know that, okay, I'm passing these as parameters. How I implement this later on, like, varies. So I'm not going to worry about curly brackets. I'm not going to worry about like proper syntax, but I do want to use that high level language that I kind of talked about earlier. Like, I want to build a food recipe where I can tell you to crack an egg in a bowl without getting specific about here's how hard to tap the egg, here's how to pull the shell apart. So what we need to do in here is we have a handful of things that we have to do. We know we have to loop over that catalog in some way. So I'm literally going to write down the words loop over catalog. So let's indent that. and we're just going to say loop over catalog. Because there's so many ways that we can actually implement that. We want to get the idea across to the interviewer of what our design skill is, but we don't want to get so specific that we're forcing ourselves into an implementation here. So inside that loop, so we're going to hit enter and we're going to continue to indent. So inside this loop, we know that we have to try to buy that item. So I'm just going to write down buy the item if I can afford it. Or if we want to be careful not to overspend our money, we can actually do a check before we buy the item. So let's clear out this line and we're going to say, skip this item if it's too expensive. Again, lots of ways that we can implement that in code, but it shows like, hey, I don't want to overspend my money. So I'm going to skip it if it's too expensive. So this could be like, if price is greater than my money, do a continue. And that's going to go back up to the for loop and so on. So if we don't skip it, now we know we can afford this item. So we're just going to write down like, buy this item. Now, the pseudocode here could turn into like multiple lines of actual code, but we're still kind of planning out the shape of what it is that we need to do. So we're going to try to buy the item. The next line is now that we bought that first sort of fancy pen, and for $4 and we got $6 left. Now what we need to write here is like repeat with less money, because that's basically what we have to do, or repeat with adjusted money or something like that. And this is, again, just saying like, hey, there's a couple of different ways that we could repeat it, but this is just getting started with the shape of the pseudocode.
Yeah.
It's EAT. Yeah. Anyway, so we're going to repeat with less money. And then after this line, what we have to do here is we have to figure out like, did that work? So after we repeat with less money, we need to figure out like, if that worked. So I'm just going to write that down. Like if that worked, and then enter and then indent, because this may turn into an actual if statement. If that worked, we can stop because we're done. So I'm literally going to write the word stop, comma, done in here, because like, how do we stop? Well, that depends on how we write that loop.
Sure.
So, but at this point, if we know that repeating that work with less money worked, then we need to stop because we're finished. After this line, if we know that we didn't stop, then we know that we didn't find an answer. Therefore, we have to put that item back. So we tried buying that item on line 78. At this step, we have to undo what we did. And so here I might just say like, put item back. So if we think about this, fancy pen comic book, we had $10 to spend. So we come in here, we've got a target value of $10. We're going to loop over that catalog. The first thing is a fancy pen. It's not too expensive, so I'm going to try and buy that pen. And now I need to repeat all of this with more money. This could be where recursion would allow us to just have just this much code and we're kind of done. If we don't do it recursively, then yeah, there is some nested work that we have to do in here. Recursion will basically take care of what we call state management. And so I'll talk you through like an approach on that. But let's just say, for the sake of argument, we're repeating all this work with $6 left. Well, we have to loop over the catalog again. Nothing is too expensive. I'm going to try and buy that fancy pen again. And then I'm going to repeat now with even less money. And so how deep do we make our nested loops? This is why recursion can sometimes be helpful. But again, you don't have to do recursion. But at this point, we can say, hey, I bought 2 fancy pens. I got $2 left. Everything on the menu is too expensive. And so at the end of this loop, this is basically where we need to send back some kind of signal saying like, hey, I couldn't find an answer with this. So outside of the loop, so on line 83, we're just going to indent one time and say that didn't work. Therefore, we need to just say like, stop, we're not done. So now if you were to say like, hey, this is kind of what I want to shape as far as my algorithm, as an interviewer now, I can ask you questions like, hey, how are you thinking about buying that item? Like, could you clarify that for me? You could start breaking that down into a little bit more pseudocode, or you could just explain it to me verbally. Or I could say, well, what does done mean? What does not done mean? It's like, well, I could use like a Boolean check, or I could, return the list of items that I bought, or return an empty list on line 83 if it didn't work. Again, you're talking through the pros and cons of like, I could do it this way, I could do it this way. But this is just roughing out the shape of what it is you want to go build. And this is why I like really short, just pseudocode, like everyday kind of phrases of loop over the catalog, because there's so many ways that we can actually implement all of this. It's still high level enough that you're planning out what you could go build, but it's not so low level, like you said, like where it looks like code. You could literally uncomment it and run it.
Yeah.
So at this point, then I could say, well, how do you know whether that worked or not? So let's go down the recursion path on this. So if we say we're going to repeat with less money, then on line 79, let's change that repeat, and we're just going to say recursion on this line. So we'll just clear out all of line 79, and we'll just do like recursion, and then with an open parentheses, we're going to say catalog, comma, target minus price, because that's effectively what we're going to do. We're going to call this method, we're going to tell this method to call itself with the same catalog, but with less money. And so now it's just going to kind of come back into itself and say, okay, I'm going to loop over the catalog again, but now I have less money to spend. So what can I buy? And so now this done, not done starts to kind of take shape on, okay, well, when the recursion comes back, like when I call this recursion the very first time, when it sends me some kind of signal of that worked or that didn't work, it's going to come back to line 79 for where I called that recursive function. And so I need to kind of collect some sort of result here. And so at the beginning of line 79, I'm going to say result equals recursion. So now on line 80, I can look at result to say, did that work or did it not work? Well, if I'm sending back a list of items, I can say my if statement could be, look at the length of that list that came back. If I'm doing a Boolean, I can just say if it was true or false or whatever. So that, again, you want to stay high level because we're not worried about how we're going to implement it yet, but we're still kind of shaping out what we need to do. Now, when we do recursion, we need some way of saying, hey, the recursion is over. We need to stop the whole thing. And that's what we call a base case. So in between lines 75 and 76, this is where we need to detect, hey, I called the recursion, but our target has been met. So after line 75, we're just going to say if money is 0. So if our money, like if we call ourselves and we have $0 left, now hit enter and indent, we're going to say stop because we're done. So now let's walk through that pen comic book. We got $10 to spend. So we come in with $10. We're not at 0. So we're going to start looping over that catalog. Nothing's too expensive. We're going to buy that fancy pen. And now we're going to repeat all of this, but now we only have $6 left. Well, we're not at 0 yet. So we're not going to stop yet. So now we're going to loop over the catalog again. We can afford another pen. So we're going to buy that pen. We're going to call ourselves recursively again with $2. So if we think about our call stack, now we're several layers in here. Now we have $2 left. We come in, we're not at 0. So we're going to loop over that catalog. Well, the pen is too expensive and the comic book is too expensive. So we're going to fall out of that loop because everything was too expensive. So now we get down to line 85. It says, hey, it didn't work. You bought that second pen that didn't work. Well, that's going to return back to where we called the recursion on line 81, where we bought the second pen. And so now that result is coming back in with some sort of signal that said, hey, that didn't work. And so we're going to skip the if condition on line 82, and we're going to hit line 84 saying, okay, put that second pen back. That didn't work. So now as soon as we put that pen back, we effectively have $6 left over, and we're going to continue our loop over the catalog and move on to that comic book. And so now we've got $6. And the next thing that we see is the comic book. Well, that's not too expensive. So we're going to try and buy that comic book. And recursively, we're going to call ourselves, we have $3 now. We're coming back into the recursion again. But now we have $3 left on our target. So we're not at 0. We're going to loop over that catalog again. But the pen is too expensive. We're going to skip it. It's going to loop to the next item, which is the comic book again. We're going to buy that comic book. Now when we call the recursion and we come in, we're at 0. And so now we can say if money is 0, so we need to stop because we're done. We need to send back some kind of positive signal like, hey, this all worked out okay. Whatever we've been collecting, that got us an answer. So now that's going to return to line 81 of where we called itself with the 1 pen and the 2 comic books. And now we're going to hit line 82 going, hey, that worked. We can also send back a signal that said that worked with this list of items. And so we send back a positive signal. That positive signal comes back to line 81 of where that recursion got called. Well, that also came back with that positive signal. And so we're continuing to just exit all the way back out of our recursion at this point. And so this is like the least amount of code that we can write to solve this problem. It's not the only algorithm. Any good technical challenge should have multiple answers. And any technical challenge that you're given where there's only one way to do it is a bad technical challenge to begin with. But in this case, there are several algorithms. That pseudocode I just gave you for kind of what you were working out as far as that process is what we call a depth first search. And it's a recursive depth first search. But the idea, the nature of this problem is what we call backtracking, where I'm gonna go down a path, and if it doesn't work, I'm gonna backtrack because I have to take a different path. So similar to like solving a maze or solving a Sudoku puzzle or something along those lines, where it's like, okay, I have a decision, I have a loop of decisions to make. I need to act on that decision, and then I need to repeat that work. And if it doesn't work, then I need to undo that decision and go back to my loop and try the next thing. And so that's every backtracking in 4 steps. You have a loop of decisions, you act on a decision, you repeat, and if that doesn't work, you undo your decision. It's every backtracking algorithm in 4 steps. And so having a good understanding of those kinds of strategies of how to recognize that as a problem, and then those high-level strategies of how do I solve that kind of problem, makes it much easier to get through these technical challenges. But hopefully, and this is kind of why I framed the initial problem, hopefully you're at a company where they're like, hey, this is what we actually do. Like I kind of stage this, like imagine that, we work for an e-commerce company, therefore this kind of problem could be applicable to us. But if you're going to work for like an insurance company and you get a problem like, hey, imagine we're an e-commerce company, it's like, that's completely irrelevant. Well, maybe in that case, you're like bundling home insurance and car insurance and whatever, and you got like the people in the white aprons. I won't say their name on your stream, but they'll love to bundle your things together. But any good technical challenge should be in line with what that company does. And I think if you run into a technical challenge where they're asking you to do something completely out of the norm of what their company actually does as a product, they're interviewing you wrong. Like it really needs to be in line. And if they're just pulling some random problem off of LeetCode, they're doing it wrong. Any technical question should be in line with what they do. So that's kind of why I framed it like, hey, let's imagine we're an e-commerce company. This could be a very real scenario of like, how do we crunch through our catalog and try to find, gift bundles for like a holiday season coming up, or Valentine's Day is coming up, or there's always some holiday coming up, right? Like, how do we bundle St. Patrick's Day things if you work for like, a drink company? Like, how do we bundle up a bunch of things to celebrate St. Patrick's Day or Easter or like whatever, Mother's Day? Like there's so many holidays that you can kind of reuse this code over and over, that this could be a good example problem for an e-commerce company. But if you're like a mobile gaming company and you give somebody a LeetCode challenge like this, like I said, their brain kind of comes to a screeching halt of like, why are you giving me this problem? This is so unrelated to what we do. That you're going to have a harder time engaging your candidate. And so any good technical problem should be in line, and it should have multiple answers. Those are my 2 takeaways as an interviewer here.
Cool. Great. Well, thanks so much, Ian. It's been a blast, and an interesting problem, and one that I'm going to go through and try to solve. I'll see if I can get a recursive solution and then a non-recursive solution as well.
Super.
Before you go, people can find you on Tech Interview, or you've got Tech Interview Guide live, and then can you mention your live streams and anything else you want to plug?
Yeah, so I live stream twice a week on Sundays and Thursdays, 6 p.m. Pacific, 9 p.m. Eastern. You're welcome to come by Twitch or just go to techinterview.guide. I've got a streaming link on there. We're also live streaming on LinkedIn and Facebook at the same time. So Twitch, Facebook, LinkedIn. Follow me. I'm Ian Douglas 736 on most platforms, or just Ian Douglas on some other platforms like YouTube. I'm just Ian Douglas, but Twitch, LinkedIn, Twitter, Ian Douglas 736. Give me a follow, connect with me on LinkedIn. I'm happy to make connections and introductions with people. But I throw up all kinds of notices out there when I'm getting ready to stream and go live. I've got guests on Thursday nights. Typically, I've got one coming up this Sunday as well. So yeah, come check us out. Ask questions live. I love engaging with live chat during those streams. Otherwise, all this content on the website, totally free. The only thing that I ever want an email address for is if you want to sign up for that email series, you can unsubscribe anytime. It scrubs you out of the database as soon as it's over. So you never have to worry about me like remarketing and spamming or whatever. I don't believe in any of that. But come check out the live stream anytime. Happy to have guests. If you want to be on the stream, I'm happy to do that too, especially for you, Taylor. I'd love to have you on the stream too, and kind of counter some of these questions from your perspective too, as a recruiter. But aside from that, go check out interviewing.io. It's a great platform as well. And I also do like live resume reviews on the stream. So again, just check out the website. You'll see all the links on there if you want to submit a resume for a live resume review during the live stream. I'm happy to do that too.
Awesome. Well, I will be on the stream soon. We'll make it happen.
All right. Sounds great.
Thank you for watching the technical interview portion of the Professional Technical Interviewee. If you want to tackle this interview question, you can find it at github.com/professional-technical-interviewee. New episodes are released on the first 4 Thursdays of each month. Find us on YouTube at youtube.com/Taylor Dorsett or on Apple Podcast or Spotify. Make sure you subscribe so you don't miss out on new episodes. And remember, keep practicing.